an integrated sterilization management system for traceability and patient safety, using GS1 standards at Fukui Hospital Shingo Kosamatsu, Department of Medical Informatics, University of Fukui Hospital, Fukui, Japan. University of Fukui Hospital Summary of the hospital. Date of opening, October 1, 1983. 6,000 surgeries/Y, 10 operating theaters, 600 beds. An Olympic game will be held in Tokyo in 2020. The flight distance from Tokyo to Fukui is about an hour. Introducing Fukui University Hospital. Data at the time of 2018. Central Sterile Services Department has 11 full-time equivalents. 1 administrator is on standby. The ratio of qualified personnel for sterilization management in the full-time equivalent is 58%. In Japan, sterilization technician qualifications are not mandatory. For this reason, the average qualification rate at national university hospitals is only 10% or less. This slide shows the fast facts on University of Fukui Hospital's CSSD team. Percentage of sets complete before 7 a.m. 100%. Inventory stockouts 0%. Average total department hours worked per week 414 hours. The feature is overtime hours. This facility only works overtime for 5 hours a week for the entire CSSD. I will explain the trend that leads to this later. The next slide is annual performance and production before and after system introduction. The focus of this slide is the increase in the number of operations. In 2018, 6,159 surgeries were performed. This is an increase rate of 25% compared to before the introduction. I will explain the trend that leads to this later. The number of items managed by the GS1 code is 4,023 in 2014, 21,872 in 2015, and 31,659 in 2016. Similarly, the number of surgical carts managed by GS1 is 3,564, 5,462, and 5,805. The number of surgical instruments managed by GS1 data matrix was 16,906 in the pre-operational estimate. Laser engraving started in 2014, and about 10,000 were engraved. In 2015, it was 16,766, and in 2016 it was 27,745. As stamping progressed, the number of stocks increased. This indicates that it was difficult to manage the exact number. I will talk about the background of the introduction. In 2014, Fukui University Hospital was rebuilding the hospital. It was decided to update the CSSD in line with the renewal of the surgery department. The Practical Guidelines of Surgical Medicine was announced in 2009 by the Japanese Association for Operating Technology. CSSD decided to ensure traceability of surgical instruments in accordance with these guidelines. This slide shows why Fukui Hospital chose to use GS1 standards. Fukui Hospital needed to ensure the safe use and traceability of instruments used in surgical procedures. The hospital was experiencing an error rate of 3,054 parts per million when counting instruments, which introduced risks associated with leaving surgical instruments in a patient's body. Furthermore, Fukui Hospital wanted to improve efficiencies in its operating rooms and inventory processes. The hospital's surgical center and central sterilization department decided to research the concept of direct marking instruments with unique identifiers, UDIs, encoded in barcodes. Continuation of slide 13. When introducing, it was important to appeal the need for the system. The Japan Association of Medical Devices Industries, JAMD, released the guideline for marking for two-dimensional symbol on steel instruments in 2006. This guideline defines the need for direct marking and using GS1 standards for symbol engraving, recommending the use of GS1 global trade item numbers plus serial numbers, and direct marking with GS1 data matrix barcodes. Furthermore, I thought it was my duty as a national university hospital to meet international standards. This slide introduces international efforts related to surgical medicine. Outside Japan, the International Medical Device Regulators Forum, IMDRF, and the U.S. Food and Drug Administration, FDA, issued the UDI guidance. Unique Device Identification of Medical Devices and the UDI Final Rules, respectively, in 2013. Both require the identification of a medical device using Unique Device Identification, UDI. For surgical instruments, UDI direct marking is expected to improve patient safety and optimize patient care. This slide introduces the GS1 code actually used at Fukui University Hospital. Fukui Hospital uses several GS1 identification keys. Global Trade Item Number, GTIN, was used for identify consumer products and services. An Individual Asset Identifier, GIAI, was used for the purpose of identify an asset. And Global Location Number, GLN, was used for the purpose of identify company location or origin. If the serial GTIN is displayed by the manufacturer at the time of purchase, use it as UDI. For example, if there is no UDI like an old steel instrument, GIAI is issued at the hospital. In order to realize international rules, we acquired the GS1 operator code of the third hospital in Japan. This slide introduces the GLN code actually used at Fukui University Hospital. The global location number indicates the location in the hospital. The photo on the left shows the GLN code at the position of the device wrapped in a sterile bag. The photo on the right is the entrance door of the operating room. This slide also introduces various GS1 codes, identifying sterilization containers. In the lower right photo, the GLN code is used on the shelf of the automatic rotating warehouse. It is also used in washer disinfector wash racks and sterilization carts. This 3D slide was made in 2012 before introduction. It is a drawing that examined the flow line using the virtual reality technology. The after-surgical count location that will later be key to success is depicted as retrieve on the upper right. There are many other places where GS1 codes are used. This slide introduces the CSSD staff workflow. Step 1. As soon as the surgery is over, after baskets will be counted for each basket in the retrieve area. Next. Collection and transportation of contaminated items after a medical device has been used. It is usually placed on a collection container which is collected by the Sterile Services Department at agreed times. Containers and trolleys that are used to transport items to and from sterile services also need to be tracked. Step 2. Receipt of contaminated item by Sterile Services Department, SSD. The department receives items for reprocessing in the designated dirty zone of the decontamination area. Step 3. Reprocessing. The items are placed in the appropriate container for decontamination. The items are then washed by the washer, disinfector, which also dries the items following the disinfection stage of the automated process. Once the cycle is complete, the machine transfers the cleaned and disinfected medical devices into the clean zone. Step 4. Inspection and assembly. Staff must check each item and notify the user if any part of the equipment is missing or damaged on receipt. Assemble the type and number according to the predetermined packing list. Packaging and sterilization. The medical devices are wrapped in medical packaging material and the packaged products sterilized. For quality control, set biomedical indicator and chemical indicator. Step 5. Storage. After sterilization, the products are allowed to cool before being stored or reissued. Check that there is no problem in the quality inspection of the sterilization process. A record is kept of items in storage and these items are dispatched on a first-in first-out basis. Step 6. Picking. As per the surgery linked to the hospital information system, we load the sterilized items for each patient into the operation cart, We call it picking. A record must be made of the dispatch of any item from this area and stock is issued on a first-in first-out basis. Step 7. Delivery. The surgical cart is taken to the appropriate operating room according to the surgical schedule. In this work, GLN is used to respond to sudden changes in the operating room. From here, we will show you a virtual tour of CSSD at Fukui University Hospital. First of all, GIAI is laser engraved on the surgical instrument. Please take a closer look.
This video will show you how to engrave GS1 data matrix on steel instrument. Fukui University Hospital uses GIAI to identify steel instruments that are already in use. First of all, medical staff take a picture of a steel instrument with a scale to be able to see the size of the instrument. In addition, they take a close-up picture of the complicated part of the instrument. After that, medical staff record the instrument name, the catalog name, and the model number to ISMS. It is very important to decide in advance how to code the instrument among medical staff. Prior to the registration, medical staff prepare barcode labels carrying GIAIs. They attach a barcode onto the instrument list. Then they scan the barcode to associate the instrument data with GIAI. Fukui University Hospital has a laser marking machine. Medical staff send the instrument data from ISMS to the machine. Then they decide the place to engrave a GS1 data matrix. A flat place is preferable. Medical staff determine the final position to engrave a barcode looking at the monitor screen. Then, laser marking is started. It takes only 15 seconds to engrave a GS1 data matrix. It is also important to pay attention to the depth of engraving. The GS1 data matrix is marked on two places of the steel instrument. After engraving, medical staff scan the GS1 data matrix with the barcode reader of ISMS. If ISMS shows the correct pictures and the instrument data on the screen, the engraving process is completed. Medical staff temporarily store the instrument in a tray, then passivation will be done all together. After the counting and collecting process, the instruments are sent to the cleaning area of CSSD. The instruments are collected in the mesh basket. Then, the basket is placed on a washing cart. Medical staff free the GII of the cart and all GDs of the basket with the mobile computer of ISMS. The mobile computer shows the appropriate washing program for the cart. The barcodes, which carry washing program IDs, are attached in the washer disinfector. Medical staff read the appropriate barcode with the mobile computer. Then, they read the barcode with the barcode scanner of washer disinfector. If medical staff scan any incorrect barcodes, the alert starts beeping. When the washing program finishes, the washing cart automatically comes out from the washer disinfector. If there is no problem with the process data such as temperature, it will be displayed on the assembly terminal. The assembled list of the instrument is automatically shown on the computer screen. Skilled staff members conduct a visual check with the GS1 data matrix and assemble a surgery set. The surgery set is stored in a container. Before the implementation of ISMS, medical staff had to wait till all instruments for each surgery set were cleaned. Now, ISMS control the timing of cleaning process, so medical staff members no more need to wait, which brought the reduction of working hours. After cleaning, the basket is placed on the table. Medical staff prepare a container for a surgery set, and the assembling process is started. Medical staff log in to ISMS with their staff IDs and select the basket and container name from the assembling list. Then, the instrument list for the container pops up. Skilled staff member conduct a visual check. Then, they scan GII or GT on the instrument and store it in the container. The name of the instrument is automatically removed from the list by scanning its barcode. ISMS has close-up picture data. Skilled staff can see those pictures for visual checks by tapping the screen. After checking and scanning all instruments for the container, medical staff press the Finish button and close the screen. The instrument list in the container is printed when the assembly is complete. The containers for surgery sets and the sterilization pouches are placed on a sterilization cart. There are multiple programs for sterilization. Barcodes that carry sterilizer IDs and program IDs are attached on sterilizers. Medical staff scan the GII of the cart, the sterilizer ID, and the program ID with the mobile computer of ISMS. Medical staff scan all containers of the cart. If a wrong container is placed on the cart and its barcode is scanned, the alert starts beeping. ISMS allows medical staff to monitor temperature and pressure in real time. In addition, ISMS displays the scheduled finish time of sterilization. After sterilization, medical staff take out the biological indicator and chemical indicator from the cart. Then, medical staff set the BI to a BI reader. The scheduled finish time of the BI test is displayed on the monitor of ISMS. Medical staff can check the time even from a surgery room with a mobile computer. After the BI test, ISMS indicates the storage location for the container using GII and GLN. ISMS checks all sterilization programs and conditions of all containers in real time. ISMS also monitors the entire process related to quality control. Collecting surgical containers from the storage cabinet to surgical carts is called picking. Surgical operation schedule is sent from the hospital information system to ISMS at the right timing. Medical staff need to collect surgical containers and place them on a surgical cart. At first, medical staff scan their staff IDs, surgical operation ID on the paper, and GII of surgical cart with a mobile computer. The mobile computer shows the container list for the surgery, and the shelf inside the cabinet automatically rotates. The cabinet stops where the necessary container is stored. The container in the cabinet is dispatched on a first-in, first-out basis. Medical staff pick it up and place it on the cart. It takes only about 20 seconds to pick a container up from the cabinet. ISMS easily identifies recall target products and unsterilized product in the cabinet. In the operating room, nurses count the number of instruments before closing a surgical incision. When the surgery is finished, the instruments are collected and checked in the collection area. Before the introduction of ISMS, this work required advanced skills, and this was a very time-consuming task for a skilled nurse. Medical staff take the basket containing the surgical instruments to the collection area. Medical staff wears infection prevention protectors during counting. ISMS displays the instrument list of the surgery on the screen. Medical staff scan the GS1 data matrix on each instrument. Then, the name of the device is removed from the list. The DPM scanner of the hospital realizes high-speed scanning, even under the situation that the body fluids adhere to devices. Low instrument may not be marked with GS1 data matrix. In that case, medical staff manually check the device using the close-up picture. The counting process is essential for the following processes. It is needed to place the right instrument on the right basket to prevent cross-contamination. The basket is sent to the cleaning area of CSSD after counting.
Thank you for watching a long-time virtual tour. This slide introduces direct parts marking, DPM, which is performed inside CSSD. First, we examined the method of marking UDI on surgical instruments. As a result, the following method was tried many times and finally established. Establishment of laser marking method. The engraving method was examined from various laser devices. The engraving depth was 20 microns, which was strong against scratches. As a measure against rust, post-treatment was performed to remove debris. Establishment of reader. When testing existing products, it took a long time to read. They often had curved or worn small 2D codes that could not be read. A new 2D code reading device was developed to solve these problems. Next, we will introduce the direct parts marking reader that we have developed with our know-how. This reader is specifically designed for DPM technology and surgical instruments. The following points are excellent as features. Optimized for fine DPM of small steel products. Made of all corrosion-resistant stainless steel. Height to reading surface approximately 65 mm. Less than 1/3 the height of conventional products. Fully waterproof and can be washed. Using this reader, you can inspect and assemble while sitting. The next 3 slides are boring with only letters, so please look at the slides uploaded from GS1 Global at a later date. This slide explains how the error rate with surgical instruments reduced. This is the result of totaling assembly errors by year. An assembly error indicates an error in the number or type of surgical instruments. In 2013, before the introduction of Integrated Sterilization Management System, the number of errors occurred was 15 per year. In 2015, after the introduction, there were 2 cases. In 2017, there was 1. There was also one in 2018. The number of operations has increased from 4,911 to 6,159 during this period. This slide shows the rate of assembly errors per surgery. With the introduction of ISMS, errors have dramatically decreased. This is because the system cannot proceed to the next process if errors remain. This slide shows that using GS1 data matrix can reduce assembly time. Staff are freed from the simple and tedious task of recounting surgical instruments. As a result, staff can focus on inspection and maintenance. This work is recorded for each basket. Sometimes multiple baskets are housed in the same container. This slide shows average assembly time per container or set by medical specialty. The point I want to emphasize is that after reviewing the laser marking device and reading device, the following points became possible. The number of scanning for marked small instruments increased. As a result, most instruments can now be identified by DPM readers. In addition, more efficient use of data from the system has become possible. The following points can be understood from the graph. As time passed, assembly time became shorter. The container list was revised based on statistical methods and usage data. By reviewing the container list, the number of extra instruments has decreased. Since containers were made common, the number of containers with the same contents increased. The staff has become accustomed to work. This slide shows the assembly time trend by staff. System support functions allow an experienced staff to work without assembly errors. A major factor is that GS1 data matrix was engraved on almost all instruments. This slide shows, with the introduction of ISMS, the number of instrument inventory assets became clear for the first time. Until then, asset managers had to predict where and how many instruments they had. Of the 31,078 surgical instruments, 24,307 were in use. Steel equipment used in hospital wards and outpatients has been managed by GS1 code since 2018. This slide shows that hospital assets can be compressed by avoiding unnecessary device purchases. In the example, there was a request to purchase a urological endoscope. However, it was confirmed from the usage history of the system that there are devices that are rarely used. We were able to avoid unnecessary purchases in preparation for purchase. These achievements reduced the cost by €10,000 per year. This long tour is approaching the end station. In this system, 2 DPM scans are executed per cycle of playback processing. This is a post-surgical scan. It scans 500,000 GS1 data matrix annually. As with the previous slide, the assembly process scans 500,000 GS1 data matrix annually. Previously, this was done with paper and pen. The system has greatly improved productivity. This slide is a picking process. Picking 53,680 containers and sets per year. Since it works in the same way, it is stored and taken out 100,000 times a year. Previously, this was done using a shelf fixed to the wall. We were able to reduce the burden on the staff's waste from handling heavy containers. This slide shows the reload time for each container in the picking process. Removing the effect of time on the first container and the last container averages 20 seconds. Using GLN data to optimize container placement has made it possible to save time. Previously, this was done by an experienced surgical nurse. This slide explains the cost benefits. From 2013 to 2018, the number of surgeries increased by 25%. This is equivalent to a 25% increase in production at the factory. During this time, the number of staff did not change. In other words, labor costs did not increase. Therefore, the labor cost per operation during this period will be reduced by 32%. In this way, ISMS has improved labor productivity. This slide explains the effect of reducing overtime hours. As mentioned earlier, between 2013 and 2018, the number of surgeries increased by 25%. The total number of CSSD overtime hours peaked in 2014. However, expanding the use of GS1 data matrix and optimizing containers have been effective. In 2018, The annual overtime hours were 249 hours. Again, the FTE is 11 people. Finally, a summary slide. Assuming that the operation in 2018 was performed with the production efficiency at the time of 2013, the effect that the value could be calculated was estimated. With the introduction of ISMS, labor costs were reduced by 33%. Overtime hours decreased by 85%. Unfortunately, the cost of reducing overtime pay has not yet been included in the reduction in labor costs. Assembly errors were reduced by 93%. I will show you this slide as an epilogue. In addition to the effects that can be calculated, there were various benefits. This is the final slide. The GS1 standard shows great promise and economic benefits for people involved in healthcare. With this announcement, I hope that many hospitals will realize the potential of GS1 and take advantage of it. I would like to thank everyone who made this valuable presentation opportunity. Dr. ELS of GS1 Global Office. Mr. Waymura from GS1 Healthcare Japan, EMS, Maikawa, who explained in a charming narration. From GS1 Healthcare Japan too. Say again thank you for your kind attention.